So when we look at calculus, calculus is this branch of mathematics that historically came into existence around sort of Newton's time, so about 400 odd years ago, right? Now, we won't really, need to worry about the sort of history lesson or anything like that. But calculus is something that is actually quite important in your everyday sort of life. And it's split into two branches. One is, as Paris has mentioned, differentiation. And that's what we'll be starting with. And then there's this other branch called integration, which we'll kind of be doing a little bit later, all right? So we will be basically looking at calculus and we're looking at differentiation sort of in particular. But while we will be looking at differentiation, let's kind of get some sort of concepts clear, right? Now, if I have, for example, a function y equals fx, and I ask you, at x equals 2, what's y? Janelle?
Y is 2.
Well, oh, whoops.
What do you
Sorry.
do?
That's my mistake there. If it's not fx, but it's x squared, yeah?
Oh, it's 4?
Right, so it's going to be 2 squared, which would be 4. Or, if y was fx, then it would just be f of 2. But let's use x squared as an example. So, if I ask you what y is when x equals 2, the answer is 4, right? What about when x equals 3? Paris?
9.
When x equals minus 5? Janelle?
25.
So if x equals, yep, it's 25, good. Yeah, so this is all pretty simple, right? You guys get the idea. To work out what y is, you sub x in, you get the answer, right? And so this is evaluating y at particular values of x. That's pretty simple enough. Okay. So what about if I asked you at x equals 1.9? What's that? You can use a calculator, but that would be 1.9 all squared, which would be 3.61, right?
Mm-hmm.
And what if I said x equals 1.99? Then y would be 1.99 squared, which is 3.960, right? And what if x equals 1.999? Then y will be 1.999 all squared. All of this is quite simple. You just type in the calculator and you do that. And we can keep going. And so on, right? So if you take a look at the values of x here, as I go down, what is my x value approaching?
4.
X,
2.
yeah,
2.
x is approaching 2. So have I got it equaling 2 at the moment in my sort of blue box?
No.
No, it doesn't equal 2, but it's getting closer to 2, right?
Yeah.
Now take a look at your y values. What's happening to the y values?
Approaching 4.
Correct. So we are basically saying that as x approaches 2, y is approaching 4. Does that make sense?
Yep.
Now note, We're saying as x approaches 2. Am I asking you what it is at x equals 2?
No.
No. So remember, we are not asking when x equals 2, y equals what? That's this question up here. That's all the way back up here. That's f of 2. What we are asking as x approaches 2, what does y go towards? And the answer here is 4. Does that make sense? So you need to now understand that we are no longer evaluating the value of a function at a particular value. We are now talking about as it approaches a value. And you might be like, well, this is pretty pointless here. And it's pretty pointless in this particular example, but that's the idea we kind of want to get used to, all right? So we need to get used to the concept of what's called a limit. And a limit can be defined very formally, but we won't really bother with that unless you do sort of HL option calculus topic. We'll kind of, deal with it informally. Think of a limit as, a number that that a function approaches. As x approaches a. In other words, we write it as the limit as x approaches a of f of x equals a. So in other words, this is your limit. This is your function. And this is basically setting up the condition as x approaches a. So for example, the limit as x approaches a, not a, as x approaches 2 of x squared is 4, as we said earlier. Does that make sense?
Yeah.
All right.
Yes.
So you might be looking at that and going, well, that seems pretty pointless. We could just sub in 2. And that's right. You could just sub in 2. In this particular case, you can. But this limit becomes more and more and more important when you can't sub in 2. Or when you kind of make things more sort of tricky, if you like. So let me start with a simple example, but it's kind of still similar. So let's say that f of x equals so, or maybe let me do it this way. All right, let me ask you, what is f of 2? If we sub 2 into that, what do we get? Well, you'll get
We don't
2.
get anything.
Yeah,
Oh.
you 2 squared times 5 times 2 plus 6. That all looks okay. Over 2 minus 2. And then you'll get, 0 over 0. And what's that?
But that doesn't work because you can't have 0 as a denominator.
Exactly. So here, your problem here is your domain is x is not equal to 2. And so we can't put in x equals 2. Does that make sense?
Yes.
So you have this function where you can't put in 2. Like it doesn't exist. But we still want to know what the value is getting close to as it gets closer to 2. Does that make sense? So let's use a calculator. So if we've got f of x equals x squared minus 5x plus 6, all over x minus 2, let's kind of do a table of values. To kind of demonstrate the point for the moment. Now we know we can't do 2. We know we can't do that. But let's, work out 1, 1.9, 1.99, 1.999, and see if you guys can figure out what those numbers are. And let's see if we see any sort of pattern to them, okay? So can you guys sub in those numbers?
Oh, I accidentally did 1.91. I
1 point,
got negative 1.1.
for which one?
1.9.
For 1.9, you got what?
Negative 1.1.
All right, I got negative 2 for that. Yeah, negative 1.1 for that.
And negative 1.01.
Yeah.
And negative, yeah.
Okay, so without doing it formally for the moment, what sort of pattern do you think happens? Like as x goes to 2, what do you think f of x goes towards? What does it look like?
0. Wait. 1.
Try again.
I mean negative 1.
Negative 1, right? Does it look like, does that make sense?
Yeah.
So this looks like negative 1. All right, so therefore, we can basically say the limit as of x squared minus 5x plus 6 over x minus 2 as x approaches 2 equals negative 1. Does that make sense? We're not doing things very formally at the moment. We're just subbing in numbers. But to give you the idea, this is where a limit becomes more useful because unlike the earlier case where obviously you sub in the number, and so obviously it's going to go towards that, in this case, you can't just go towards that. You can't just sub in the number. You get something that's nonsensical and you can't work out what that number that is. But there is an answer. The answer is minus 1. Can you see that? Now, let's do a very similar thing. I'm still going to use the same x and fx. And now I'm going to go for numbers above 2. So let's this time go from 3 down to 2.1 to 2.01 to 2.001. So we know there's nothing there. So what numbers do we get?
Negative 0.999.
Do we all agree with the numbers?
Yeah.
All right. So let's now think about getting, as x gets closer to 2, so this time going from 3 towards 2, what happens to fx? As x approaches 2, fx approaches
1 huh?
No.
positive or
No,
negative?
negative 1.
Yeah. So we still have limit as x approaches 2 of x squared minus 5x plus 6 over x minus 2 still equals negative 1. Now, Here's the thing. This is actually called a left-hand limit. In other words, we're approaching x from a smaller value. So it's x approaches 2, but from a smaller value. So these two technically could be different. Now, in my example, the answer is the same, but still we're evaluating different things. So this is the left-handed limit. So I really should be writing 2 negative. This negative just means I'm approaching 2 from below, from the negative side of 2, if you like. And I should be writing 2 positive here, from the upper side of 2. So as I approach 2 from below, or as I approach 2 from above, and furthermore, we should be writing a limit here. So are we approaching -1 from the lower side of, are we going from the negative side of -1 or the positive side of -1? Are we approaching -1, from a more negative number or from a more positive number?
More negative?
Exactly. So more specifically, we should write -1 on the negative side. And similarly here, when we approach 2 from 3, we are approaching it from the positive side. And we see that we are approaching -1, but are we approaching from a more positive number or from a more negative number compared to -1?
More positive?
Yeah, so that's why this is -1 to the plus. And this is your right-handed limit.
Well, why is it more positive?
Because if you think about your number line, -1 is here, right? And you're going from 0 to -0.9 and so on. So you're going this way, right?
Yeah.
But from the point of view of -1, this is the positive side of -1 and this is the negative side of -1.
Oh, okay, yeah.
So, you're approaching -1 from the positive side.
Yep.
On the other hand, if you are going from -2, then you're going this way. And so you're approaching it from -1 on the negative side. So you're comparing, to your final destination. Are you coming from the, the right-hand side, the positive side, or are you coming from the left-hand side, the negative side of that destination? So if you look at these numbers here, they go from -2 towards -1. So your numbers are getting bigger, but what they are doing is they're getting towards the negative side of -1, right? And these numbers, they're getting smaller, but they are going towards the positive side of -1. Does that make sense?
Yep.
In other words, as long as your number is bigger than 2, your number will be slightly bigger than -1. As long as your number is smaller than 2, your number will be slightly smaller than -1. And we will get as close as we like to -1, but technically, in this situation, we'll never sort of get there. But that is representing sort of the ideal limit. Do you see what I mean? We're never getting to -1, actually. But this is the sort of, we could get as close as we possibly want. We could add lots and lots and lots of 9s to this. We could add lots and lots of 0s here, but we'll never actually get -1 exactly. Does that make sense?
Yeah.
So this is the concept of a limit. A limit is the idea that we can get close to a number. Now, sometimes you can actually equal that number, like here. But that's not our question. Remember, when we're asking a limit, we're asking about what happens as we get close. Whether we can actually equal that number, in this situation, or not, like in this situation, doesn't matter. What matters is what the limit is, regardless of whether the value exists at that point or not. When the value exists at that point, you might think, well, kind of pointless. But when the value doesn't exist at that point, then that's kind of when it becomes more important. Are we clear on that? Yeah.
Yes.
Okay. So in other words, then, we have different limits. We have what's called the left-handed limit, which is the limit as x approaches a from below of f of x. And let's call this, limit, left-handed limit. All right? Just making it up to be clear. You've got the right-handed limit. Normally we might use a letter like A and B, but so this is the limit as x approaches A from above. Now, do these two have to equal? Do you think these two have to equal?
No.
Yeah, they don't, all right? So they definitely don't have to equal. And there are probably some examples I can give, but hopefully this example won't confuse you too much because we'll start to use infinities. But you know what this graph looks like, right? What does this graph look like?
Do I know?
You should. It's a hyperbola. You guys have done this, right?
Oh, you mean the y equals to 1 over x?
Yeah.
Yeah.
So let me ask you, what is the limit as x approaches 0 on the positive side of 1 over x? You can look at it graphically if you like, but as you get closer and closer to 0 from the positive side, what happens to the
It
y
goes up.
value?
Closer to 0?
Goes to 0. The y value?
Oh, you mean y? It
Yeah,
goes,
yeah. Well, we're looking at 1 over x, right? So x goes to 0, but what happens to the 1 over x, which is y?
It goes up
goes up.
To what?
to whatever.
So
Infinity.
let's not be too formal about it. Let's say positive infinity. Technically, I shouldn't write that. Technically, I should write lim as x goes to 0 plus y goes to positive infinity. Technically, I shouldn't have an equal sign, but let's just not be very, let's not worry about the dotting your I's and crossing your T's right now. Let's focus on the concept. What about the limit as x approaches 0 on the negative side?
Y goes down.
To
Infinity.
positive or negative?
Negative?
So this is, if you like, your right-handed limit, right? You're doing 0 on the positive side. And this is your left-handed limit, right? You're doing 0 on the negative side, right? Does that make sense? This is our right-handed limit, and this is our left-handed limit. So, are they equal?
No.
No.
No. And so we can definitely have situations where the right-hand limit and the left-handed limit are equal, like what we had here. And we can also definitely have examples where they are not equal, like here. So remember, there is the limit from the right-hand side, and there is the limit from the left-hand side. And there is no guarantee that these equal. These might not equal. So when you are evaluating a limit, that's why you should be paying attention to, are you evaluating from the left-hand side or from the right-hand side? Because the answers could be very different. Does that make sense?
Yeah.
So the left-handed limit, as we said, is the limit as x approaches a from the negative side of f of x. The right-handed limit is the limit as x approaches a to the right of f of x. Now, if the limit as x approaches a from the left equals the limit as x approaches a from the right, if that happens, then we say the limit as x approaches a of f of x equals L. In other words, if the left-hand side limit and the right-hand side limit are the same, then we can simply say the limit without talking about the left or the right is that limit. So, example, y equals x squared. Let's use the example we had earlier. Y equals x squared minus 5x plus 6 over x minus 2. The limit as x approaches 2 positive of x squared minus 5x plus 6 over x minus 2 was -1. On the, was it on the negative side or on the positive side? 2 plus was on the positive side. The limit as x approaches 2 negative of x squared minus 5x plus 6 over x minus 2 is -1 on the negative side. Now, because these are equal, we can therefore just say that the limit as x approaches 2 of x squared minus 5x plus 6 over x minus 2 equals -1. We can simply say that now, because we've shown that the limits on both sides are equal and they're both -1. One's positive, one's negative, that's fine. But the fact is that it's the same number. And so we can simply rewrite and say the limit of this function as x approaches 2 is equal to -1, despite the fact that for this function, the domain is x not equal to 2. So although we can't work out what the value of this function is at x equals 2, because clearly you can't put 2 in, we can find the limit for this function as x approaches 2. Does that make sense?
Yeah.
Yeah.
Okay, so if you're trying to work out a limit, then I guess the easiest situation is to start with situations where it can be that number, like x squared, and then you basically just sub in that number usually, right? But you might get questions like this where you can't. And, you know, we've worked out it's -1, but we've kind of done it through this kind of very laborious way of subbing in numbers, right? So there's different ways to approach this. But basically, there is the graphical way. So to evaluate limits, we're going to be going through some methods, so like some algebraic methods, and also sort of graphical methods. So if you think about it, let's think about your y equals x squared. It looks something like this. Now we know we have this point 2, 4. If you just look at this graphically, as you go, this is x equals 2. As you go from, as you approach this point from the right, what does the y value approach? Can you see as you move along the curve? What happens to the y? As you get kind of, you bring it closer and closer and closer.
Approach 4.
Exactly. So if you understand what the graph looks like, you can kind of just look at it, right? Now, if you've got a situation where you've got this and you're approaching, x is approaching 2 from the left, then y is approaching 4 negative. And if you know the graph of y equals x squared here, it's very clear that, you know, as you go from the right and from the left, they'll both approach this point and there's no difference, right? That's pretty clear, right?
Mm.
And it just equals that. Right. Now, if you have something like y equals, you know, 1 over x, as we looked at earlier, then you could see that the one approaching to the right does not equal the one on the left. But let's kind of do another one. For example, let's say y equals absolute value of x. You guys remember what this graph looks like?
Hello, sorry, I had a little trouble joining.
Yeah, I saw you rejoin a second time just then. So yeah.
Yep.
All right. So
Is this the first thing, is this the first slide we
no,
doing?
we're up to slide 7. We started more than half an hour ago. Yeah.
Really? I thought we start at like 5:30.
No, it's fine.
Oh, damn. Oh,
It's okay. I've
could you
recorded
send me
it.
the slides?
I have recorded it. I've been recording it just so in case this happened. So yeah.
Okay, where can I find the recording?
You might remember that it looks like this. So if you've got y equals absolute value of x, let's consider approaching 0 from the positive side. So if you're here and you're going down the curve, what y value would you approach as you go towards 0?
0, 2.
Yeah, 0 positive or negative?
Negative.
Actually, are you approaching 0 on the positive side or the negative side of 0?
Positive.
Positive, right?
Oh, that's right. Yeah.
We're not worried about what happens to the numbers. We're worried about on which side of 0 you're approaching. So as x approaches 0 from the negative side, what's y approaching?
Positive.
0 from the positive side. So I'm kind of just showing you the basic idea we're talking about here. I'm going to draw some graphs. Some graphs you might not be comfortable with. You might not know what they are, but others you might. You probably won't know what that looks like. But for your intents and purposes, we know that x can't equal to 0. And basically, let's just say that, you know, it looks like this. Okay? I'm not going to draw the whole graph out. So let's consider as x approaches 0 from the positive side, what does y approach?
Zero.
Not 0. 0 is here.
One. Wait. As x approach 0.
As x approaches 0, so you're going more and more left, what's the y value you head towards?
1.
Correct. On the negative side. And as x approaches 0 from the negative side, you're going to approach 1 again from the negative side. Now note, f of 0 does not exist. This is a situation where it just doesn't exist. Now, I could draw all sorts of graphs to kind of give you guys the point. They might not be graphs you like or are, you know, comfortable with, but let's add a graph like this. So let's say I wanted to work out as x approaches 0 positive, what does y approach?
1. Positive.
Oh, yep. As x approaches 0 negative, what does y approach?
-2.
On the positive side or the negative side of -2?
Negative.
Yep, because you're smaller than -2. Good. So you can see that if you know what the graph looks like, then it's pretty easy. Like that's the whole concept, right? We don't care about what it is at 0. It's -2 in my example here at 0. It's nothing here at 0. But you're just basically looking as you get closer and closer, what does that approach, right? Now, we don't care about the fact that it jumps to -2 at 0. When we were evaluating this, we cared about what happens as we got closer, not when we got there, but as we got closer. And it just went to 1. Even though with this open circle here, it is never, ever, ever 1. Does that make sense? Can you see that? And with this open circle, this function is never actually 1. Well, the moment you hit 0, it's at -2. But just before you get to 0, it is getting as close as possible to 1. Does that make sense?
Yeah.
Good.
Yeah.
So I'm kind of just showing you how you might use graphical methods if you know what the graph looks like to kind of work it out. Now let me show you some algebraic methods. So you might like, before we continue, let me just show you one more or another 2 more, just to make sure that you kind of get the idea of certain sort of special-ish cases. Let's just consider that point 1, 1, and let's consider this point 1, -3. So for this one, as x approaches 3 from below, or from above, what does y approach?
Two positive.
Yep. As x approaches 3 from the negative side, y approaches
2. Negative.
Yep. And note, in my example here, because of the open circle, note that, you know, there is no f of 3 does not exist. All right. And if we take a look at this example here, as x approaches 1 on the positive side, what does y approach? So if you're approaching 1 from the positive side, that means you're starting bigger than 1, right? And you're going left. So
1 negative.
yeah, because you're getting closer and closer and closer to that, right? We're not, again, we don't care about what the value is at 1, which is -3. We don't care about the value itself. We care about what we get close to. And you can see that just before 1, as long as you're not at 1, but anything before 1, you're basically getting very, very, very close to 1, but on the negative side. As x approaches 1 on the negative side, y approaches
1 positive.
correct. And note, in my example here, f of 1 does exist. F of 1 equals -3. And in my example here, it does not equal the limit. So you can have situations where the limit exists and the right-hand limit and the left-hand limit are equal, but the function either doesn't exist, have a value at that point, like here, or it can even have a value that's just not there. Just depends on how you define it. Okay. Does that make sense?
Yeah.
But if you have a nice kind of what you guys might think of as a nice normal curve. So if a function is continuous at a, at x equals a, then, well, you know, the limit as x approaches a of f of x will just equal f of a. So if you're talking about nice, simple functions that are the ones that you're kind of used to, where, you know, it's got a straight line or it's continuous. In other words, simply think of, there's a formal definition of continuous, but think of continuous as like, you know, you can draw, informally, think of it as you can draw the function without lifting off your pen. Right? Informally, think of it that way. There is a formal definition, but you might not worry about it. So clearly, something like this, I can't draw this function without lifting my pen because, you know, I have to draw this dot, right? Technically, to draw this function, I have to lift my pen because I have to, you know, have this cut open here. So I should be going here and then leaving a gap and then doing it again. Does that make sense? This is not continuous because I'm going here and then I have to lift my pen to go here and start here. This is not continuous because once I go here, I have to lift my pen and then do it again from here. This is continuous because I can kind of draw this and then change direction and go up. And this is continuous and so on. Does that make sense?
Yeah.
So if you're trying to find limits, then your easiest situation is when you've just got a function that is continuous at the point you're trying to find that, and you just sub it in. Kind of like what we did for the x squared. X squared is continuous at 2. And so we just sub in the number 2 and we're done. The limit is 4. Right? And that is pretty boring, but that will be a large part of your initial exercises. So it's slightly more involved if the function is not continuous at x equals a, and you're trying to find its limit. All right, so I won't really bother about the, you know, ones where you just sub it in because I think you guys can deal with that. It's more or less the same. So let us look at our previous example. Y equals, or f of x equals, x squared minus 5x plus 6 over x minus 2. Now note x can't equal 2, so this will clearly not be continuous. At x equals 2. Now, if I draw out this graph for you, then you guys can probably tell what the limit is. And we know from our earlier subbing in numbers that what the answer is as well. So Tiffany, I'm just referring back to this example. Okay, so when you look at the recording, you know, we've subbed in numbers to work out that the limit here is going to be -1. Okay. So we know the answer. We know the answer is going to be -1. And I could draw it out for you. And that will hopefully help you see it's -1 as well. But let's assume that you don't know what the answer is. And the question asks you to find the limit as x approaches 2 of x squared minus 5x plus 6 over x minus 2. Now, unlike a simple question, like limit as x approaches 2 of x squared, where you can just sub in 2 squared to get 4, unlike this question, we said earlier, can we sub in 2?
No.
No, we cannot. And the reason we can't is because once you sub in 2, you're going to get a 0 in the denominator, and so you can't work it out. And so when you have questions like this, you're going to have to find some way to deal with them. And one of the question types you're going to get is this question type, where it's not continuous. But if you have a polynomial over a polynomial, then what you really want to do is try and sort of cancel out this x minus 2. So thinking about it algebraically, can you guys factorize the numerator for me? What does the numerator factorize into?
X minus 6, x plus 1.
Nope. Oh. Yeah, that doesn't work. Because if you have x minus 6, x plus 1, you're going to get minus 6, not plus 6.
Oh, negative 2 and negative 3.
Does everyone remember how to factorize quadratics?
Yeah.
Tiffany, Janelle, you guys all comfortable with that?
Yeah.
All right.
Yes.
What do you guys notice about the x minus 2?
We can cancel it out.
They can cancel. So therefore, it's now kind of equivalent to working out the limit as x approaches 2 of x minus 3. And this you can just sub in to get negative 1. So if we didn't sub in numbers, and if we don't know what it looks like, then this is what you would do. You would basically try to cancel out the denominator. And for the questions you get, you should always be able to do this. They will be rigged so that you can cancel it out. So you should be looking at how you could use algebraic sort of methods like factorizing to kind of get this out and then cancel it. Does that make sense?
Yeah.
So therefore, kind of, I'll put this on the same page. Graphically, we've now actually shown that f of x equals x squared minus 5x plus 6 over x minus 2 is actually just simply x minus 3, where x is not equal to 2. So if I were to graph this, it's actually just the x minus 3 curve or line. It's really just this. With one caveat. Open circle at 2 minus 1. This is the graph of y equals f of x. It's just a straight line with a hole in it. And now, if you look at the graph, what happens as we approach 2 from the right? So think about it. As x approaches 2 from the right, what happens to y?
Y approaches negative 1.
Positive.
Positive.
Yep.
Positive.
And as x approaches 2 from the left, what happens to y? So as you move up and up and up and up and up towards x equals 2, the y value is going to approach
Negative 1.
on the positive side or on the negative side.
Negative.
Oh, guys. Okay.
So yeah, I know you're trying to catch up, Tiffany. And yeah, if you go over the earlier stuff we talked about, this might make a bit more sense. Hopefully you're getting some of it now. But yeah, going over what we went over earlier would be helpful for you as well.
I already feel like I'm catching up.
Yep, good. So if you look at what we did when we, subbed in numbers, our answers match, right? If you approach 2 on the positive side, you approach -1 on the positive side. If you approach 2 on the negative side, then you approach -1 on the negative side. Exactly. And so limit is just talking about this thing. Now remember, I'll stress again, and I know I keep saying this, but it's important. We don't care about what it is at 2. That's not the question. That's if I ask you what's f of 2. That's a different question. But if I ask you for the limit, that's not about what it is there, which may or may not exist. We care about what it approaches. In this case, -1, either from the positive or the negative side, depending on whether from the right or the left. Does that make sense? Are you guys all happy with that?
Yes.
Yep.
Good. All right. So now we've been looking at limits, and limits is central to the idea of calculus. We're doing it kind of informally. Now so far, we've evaluated limits for x approaching some value a. Either the positive or the negative. Let's now expand this concept to evaluating limits as x approaches infinity. We now want to kind of do things like this. So let's start with something fairly easy. And I think something like this, you can more or less do numerically, or if you guys aren't comfortable with it, then you kind of want to do graphically. But one of these 2 ways might be the kind of ways you might want to think about it. So we know this is y equals 1 over x, all right? So if you just look at the graph, what do you think happens to, as x goes to positive infinity, what happens to 1 over x?
Gets smaller.
How small? What does it approach?
Infinitely small.
So what number does it approach then?
Oh.
On the positive side or the
0?
negative side?
Right.
Positive?
Yeah. And technically, it's probably because, it's generally better to say as x approaches infinity. I mean, the equal, you generally shouldn't write equals infinity. So this was 0, so that's kind of okay. So this notation is okay, but sometimes you might also see as x approaches positive infinity, 1 over x approaches 0 plus. And similarly, as limit as x approaches negative infinity of 1 over x, what does that approach?
-0.
Yeah, 0 on the negative side. Exactly. And so if you have a graph, hopefully it's fairly obvious. Now, if you didn't have this graph, so imagine this graph wasn't here, then I guess the other thing you can kind of do, so let's imagine that this graph is not here for the moment. And, we're obviously starting with something simple, but let's think of it sort of algebraically. Now, you can't actually do algebra with infinity. Like, you can't just sub in infinity. But if you just think about it conceptually, right? This is basically saying what's going to happen to 1 over a very, very big number. And as you make this bigger and bigger and bigger. And 1 divided by a very big positive number will therefore go towards?
0?
As your denominator gets bigger, your number will get smaller. So even without the graph, hopefully you can see how you can get that it will be 0. And because it's a positive number divided by a positive number, then it will still be a positive, but very small. Now, a limit as x approaches negative infinity will be 1 divided by a very big negative number that's getting bigger. And so it's going to be a negative number because you've got positive divided by negative. So think about the fact that this was a positive number divided by a positive number, but this is a positive number divided by a negative number. So you know your answer is going to be negative. But because it's 1 divided by a massive, massive, massive number, as big as you want, it's basically going to go to 0, but on the negative side. Does that make sense? And that, therefore, ties in with our graph. Are you guys happy with that?
Yeah.
Okay. So, let's take a look at some examples. Let's take a look at, for example, the limit as x approaches infinity of x over 1 minus x. So if you have something like this, it might not be that easy for you guys to work out, right? And the reason I say that is because you guys don't know what this graph looks like, I don't think. And what happens if you sub in infinity? So if you try to sub in infinity, you're going to get sort of infinity over 1 minus infinity, right? Like, let's just kind of think of it as that. So in your numerator, you're going to get a really big positive number, right?
Yeah.
In your, I mean, 1 minus infinity, does that 1 really matter?
No.
Not really. So you're going to get some big negative number, right? Like, we're basically going to get positive infinity divided by negative infinity, right? Basically. Yeah? Now, we know positive and negative is going to give us a negative. That's not a problem. We can easily get that. But the question is, what number are we going to get?
1.
Well, that probably is the correct answer here, but do you really know it's 1 though? Because if you take a big number, right, and divide it by another big number, how do you know which is bigger? You see what I mean?
Yeah.
At this point in time, you really just know it's some big number divided by some other big number. You don't really know which one's bigger at this point in time. So, do you see the problem? So, while the answer here will be 1, you can't assume that it is 1, because I can give you examples where, you know, it could be 5, it could be 10, it could be 100, it could be a half, it could be, I could make it 0. Oh, yeah, I could, 0 is a bit hard. I could make, yeah, no, I could make it 0. So that's the trouble you have, in the sense that you're going to not really get something that all that clear. So in other words, we're now going to sort of introduce a technique to deal with that. So in this situation, you're going to get infinity over infinity. Now, there are kind of 2 ways to go about it. I kind of generally prefer the second way, but I think many students might prefer the first way. So I'll just show you the first way first. So basically you divide by the highest power of x. So in this case, in our example here, what's the highest power of x?
1.
Right. So we're simply saying, if we're using method 1, we're saying that we will divide everything by x. Okay? Because x is the highest power. Now, once we do that, have we changed the fraction itself? Have we changed the value of the fraction?
No.
Because it's a fraction. We did the same thing to the numerator and the denominator, and so nothing's happened. So now think of the numerator. What is the numerator?
1.
Yeah, this is your numerator now. So this will just be 1. Now, denominator, we don't want to kind of leave it like this. What we often do is we kind of do it like this. We split it. Okay. Does that make sense?
Yep. Okay.
So now we're going to get, and x over x is just 1, right? So nothing's really changed except the way I wrote it, right?
Yeah. we
Now,
follow.
what happens as x goes to infinity? Does 1 change?
No,
Does minus 1 change?
no.
What does 1 over x go towards then?
0.
So basically, you can just now basically say, well, that's basically 1 over 0 minus 1, which will be -1.
Oh.
And I did say that, you know, -1 is the right answer here, but I just want to stress that while -1 is the answer here, you know, you can't assume infinity divided by infinity is 1 because, you know, like, for example, there are an infinite number of even numbers and there are an infinite number of multiples of 3. But I think you would all agree that there are more numbers that are, you know, even than there are multiples of 3 or multiples of 100, right?
Mm.
All of them, there are infinite number of, you know, multiples of 100, but you would agree that there are more multiples of 2 than there are multiples of 100, right?
Mm-hmm.
Yeah.
And so they're both infinite, but the infinite number of multiples of 100 divided by the infinite number of 2's is not 1. It's, you know, going to be 50.
Mm-hmm.
Do you see what I mean? So what I'm basically getting at is you can't assume infinity divided by infinity is any number at all. It depends on the situation. And so one way to resolve the situation in the cases you've got here is to do this. Okay. Now you might prefer this method, and for finding the limit, that's more than fine for questions like this. Just make sure you divide by the highest power of x. So when I say questions like this, I mean a fraction with a power of x in the numerator and a fraction with a power of x in the denominator. You pick the highest power of x in the numerator and denominator, and you divide everything by that power. The end result will be, you know, some numbers and some 1 over x's or 1 over x squared and so forth. And the nice thing about that is that all of these will go to 0, letting you to work with what you've got. Okay. So you can do questions that way, and that should be fine for working out the limits. I'm going to show you another way, which you may or may not like as much. But the reason I like the other way is it kind of gives you more information. Okay. So the other way is to is basically to divide, actually do the division. So divide the numerator by the denominator. And you can either do this the sort of long way, or you can kind of do it this sort of tricky way, if you like, or algebraic way. So do you guys want to see the long way or the tricky way or both?
Both.
All right, so let's do it the long way first. So the long way is just literally long division. Have you guys done long division with polynomials yet?
That's a good question. Paris, have we?
I don't think so.
Okay, so what I'm going to show you, you might not have done, and you might not need to really worry too much about, but it is a technique that does exist. Now, you might not be familiar with it, so I'm just going to show you what it is. And just keep in mind, like, you know, if you have something like 700 divided by, let's say, you know, 3, right? Then, you know, long division is pretty boring. You just go, what's 7? You know, how many times is 3 going to 7? You say twice, and then you multiply 3 times 2 to get 6. Then you subtract, you know, 1, bring down the 4, then you go 4, and 12, and then 21.
Oh yeah, we know long division, but
Yeah, I know. I'm just like, There's a
No.
reason I'm doing it. There's a reason I'm doing this, right? And that's basically how you do long division with numbers, right? Now, if I do, let me show you firstly long division with a more complicated one, because otherwise you might not see how it relates. So let's say I want to work out x cubed minus 2x squared plus 4x minus 7 divided by x minus 1, right? So just like we did with numbers, what you're going to do is just work out, hey, what do I need to multiply x by to get x cubed? And what do you need to multiply x by to get x cubed? I'll make that x plus 1 to make things a little bit nicer. All right, so I want to get x cubed. How do I get x cubed from x? What do I need to multiply by?
Times x squared.
Exactly. So that is your first step, it's x squared. And then just like your long division here, once you work out it's 2, you go 3 times 2 is 6. And so we go x plus 1 times x squared will be x cubed plus x squared. And just like you did with long division, you then subtract. So you're going to get x cubed minus x cubed, which is 0, and that's what you need. This thing must go away completely, or else you've made a mistake. But then you've got this leftover part, minus 2x squared minus x squared will give you minus 3x squared. And just like long division, you then bring down your next, digit, if you like, which is plus 4x. And you repeat the process. What do I need to multiply x by to get minus 3x squared? Because this has to go. What do I need to multiply by?
Negative 3 squared. Oh, negative 3x.
Yep. So that will give you negative 3x squared minus 3x. And then again, you do the subtraction. So that subtract that goes. 4x minus negative 3x, this is a very common mistake. Often people write, like minus like x or something like that. But remember, it's minus the whole thing. So it's actually 4x minus negative 3x. So this is 7x. And then you do the same thing. What do you multiply x by to get 7x? And your answer is positive 7. And then you'll get 7x plus 7. And so we'll have negative 7 minus 7, which is negative 14. So in other words, we're saying that x cubed minus 2x squared plus 4x over 7 divided by x plus 1 equals x squared minus 3x plus 7 minus 14, plus negative 14 over x plus 1. That's the sort of result of the division, if I'm doing it sort of the long way. And if I apply that here, I'm dividing x by negative x plus 1. So I only need to do one step. What do I need to multiply negative x by to get x? And the answer to that is?
Negative x.
Negative 1.
Oh,
If it's negative
well,
x, you get
sorry.
positive x squared, right? So that means you'll get x minus 1. X minus x is 0, exactly what we wanted. But 0 minus negative 1 is going to become positive 1. And so our answer for x divided by 1 minus x is now negative 1 plus 1 over 1 minus x. That's the result of the division. And this is analogous to, 7415 divided by 3 is equal to 2471 and 3 over, and 2 thirds. Right, the remainder goes in here. This is the remainder. And this is the divisor. So same thing here. The remainder is 1, so it goes here. And the negative x plus 1 goes here. Does that make sense?
Yes, it
Right.
makes sense.
So how does that help Well, remember, the question was to find the limit as x approaches infinity of x over 1 minus x. And I have just done some work to basically rewrite that fraction as -1 plus 1 over 1 minus x, right? That's what I've done, right? Now think about this. As x goes to infinity, what happens to the denominator here?
Becomes infinitely negative.
The denominator
So
becomes
there's
huge and negative,
0
right?
to the negative. Negative 0.
So the whole fraction here will become -0. Do you guys see that? This number will become huge and it's got a negative. So this will be the denominator will be a big negative number. So this fraction will be a small, very small negative number. It'll be a -0 basically. Now, is -1 affected by x?
No.
No.
No. So basically it's going to be -1. And this is just going to be 0. And even more specifically, we can say it's -1 to the, to the negative. It's the negative because that's a -0.
Oh, okay.
So we'll get the same answer, right? We get the same answer, but I feel like this way is better, just because, you can, one, see more clearly what's happening, as well as also get some more information as approaching it from the negative side. Whereas doing it that way, you don't really quite get that, right? Now, if I were to do it the sort of tricky way,
Wait, sorry, I'm confused. How do you know that it's approaching from the negative side?
well, you told me that this is a 0 negative, right?
Yeah.
So if you've got -1 plus a small negative number, is it smaller or bigger than -1?
It doesn't change? Bigger?
Well, it will change a
No,
little.
Smaller. Smaller.
Yeah, so it's on the negative side. It's smaller.
Oh, okay.
Does that make sense?
Yep, I understand now.
On the other hand, if this was like, 1 plus x, then this would be a positive 0, in which case it would be -1 on the positive side, right?
Okay.
So the so-called tricky way to do it is really not that tricky. And really, I'm still going to get, I'm just going to do this, I'm still going to get here. I'm just not going to do it this way, all right? This sort of long-winded way. So I'm going to start with the same thing. But instead of sort of, like dividing, what I will probably do is I will recognize that, I can write the numerator as a multiple of the denominator plus or minus something. Because see, if I multiply the denominator by 1 minus x, that's -1 plus x, right? You guys agree this is -1 plus x, right? You agree with that?
Yep.
Now, we don't want -1 plus x. What we do want is x. So therefore, x must equal -1 minus x plus 1, right? I've gotten to the exact same place without doing long division.
Wait, how do you know it's negative bracket 1 minus x?
Well, I know I want to cancel this, right? So I deliberately force in the denominator.
Oh yeah, okay.
So in terms of like, how do I know it's 1 minus x? Well, I don't. It could be anything, but I'm deliberately picking this because I wanted to cancel with the denominator.
Yeah.
But once I pick the bracket, what is out, what I need to multiply in front of the bracket is determined by what's inside the bracket.
Yeah.
Does that make sense?
Mm-hmm.
Yeah.
Oh, okay. This is so trippy, but it's cool.
Yeah. And you know what? The reason why I like this way better than sort of, this way, not only have I worked out the limit very easily, because, it's pretty easy to read off the limit is, -1 because this will just go away. not only do I know that it's going to have more information, it's going to know it's going to be -1 on the left, but if you are comfortable with your graphs and your transformation, this is easy to graph. I've got it in very easy to graph form. It's -1 plus 1 over, if you like, negative of x minus 1. In other words, from this, I can tell that -1 will be your horizontal asymptote, because as x goes to positive and negative infinity, you'll go towards negative. So let me do it on a new sheet. So I've got it as y equals -1 plus 1 over negative x minus 1. So this then means I know that my x can't equal 1. So there's a vertical asymptote at 1. Okay. I know that my y can't equal -1. Now, when x equals 0, y equals 0, it's a negative parabola, which means that it's going to, instead of going this way and this way, it's going to go this way and this way. And so we already have our graph. And that's another reason why I like doing it this way, because not only does it help me work out the limit, I can basically read off from this what the graph will look like. What I'm basically saying is treat it as a y equals 1 over x, but then, flip it because it's negative, then shift it to the right by 1 because of the x minus 1, and then shift it down by 1 because of the -1. And that will give you this graph exactly. You've got 1 over x that looks like, 1 over x looks like this. Because of the negative, you flip it, and then you shift it right and down by 1. And that gives you our final graph here. And if you have an idea of what the graph looks like, then that also helps you work out the limit. Does that make sense? And if we look at the graph here, as x approaches infinity, what happens to y?
Approaches -1.
On the positive or negative side?
Negative.
Yeah. And that matches what we've said all along.
Yeah.
Does that make
Wow.
sense?
It's back full circle.
Sorry, Tiffany, what did you say?
Nothing, just side comment.
Okay. So that's basically the concept of limits. Now, I went through that quite slowly, but hopefully I'm trying to show you sort of all the different things. Limits, you'll do a little bit on it. It's something that I think a lot of students might struggle with. That's why I spent a bit more time on it. If you really want to know calculus well, ideally you want to know calculus. If you want to know calculus well, ideally you're good with limits. You can probably sort of get by without it if you kind of want to kind of gloss over the details. But if so when we do calculus, you'll see why I say you can't really do it fundamentally without understanding limits. But if you don't want to care about the fundamentals, then you can kind of ignore the limit and kind of work around it just with the rules you've got. But let's start with trying to get your limits, sort of understand what limits are. And next week, we can sort of start more on how to apply this limit to calculus and how that relates to differentiation and so on. So for homework, can you guys do chapter section 14A and 14B of the book that I've sent you guys previously? those are basically all about evaluating limits, and considering all the techniques we've covered today, you should be able to do 14A and 14B without too much trouble at this point.
Yeah, sure.
Right.